Just a show of hands, how many of you have played around with Azure so far? Awesome, that's great. How about Databricks on Azure? Okay, great. So in this session, we're going to look at Databricks on Azure, and specifically Spark doesn't exist in isolation, so we're going to look at the integration points with the rest of the platform and customer needs as far as integration goes. My name is Denzil Ribeiro. I am part of the Azure Customer Advisory Team, which is part of the Azure Engineering, and this is Madhu, who's my teammate, and together we hope you enjoy this presentation. So objectives, we'll look at what a typical customer deployment looks like on Azure Databricks. We'll understand some integration requirements with other Azure services and some best practices on Azure Databricks. So the first point to Azure Databricks is you create a workspace. You take a resource group, create a workspace. On creation of the workspace, this talks to the control plane. The control plane also has endpoints for REST APIs. So any REST API call actually goes through this control plane, and they're per region. And on creation of workspace, it effectively creates a locked resource group that has all the resources required by Databricks for your clusters and so on and so forth. This is a locked resource group. You cannot create any custom resources within it. Creates DBFS, which is a layer on top of Azure Storage, also a VNet, and a network security group, or NSG. Then a Hive metastore is created, which has your metadata about all your Hive tables. And then creation of the cluster results in creation of the VMs, right, based on the sizes you specify. And clusters on Databricks are ephemeral in nature, so as they auto-terminate or you shut them down, those VMs disappear from your resource group. Communication to other resources, say you have a SQL database or Oracle database, and Databricks needs to communicate with it. Without VNet peering, you have to open those resources to the internet. So VNet peering is a way to access resources in another resource group and tie those VNets together. Also allows you to talk to on-prem resources via express route. So what VM should I pick for my workload? A common customer question in terms of VM sizing, right? So we have a ton of VM SKUs in Azure, and each of them has a bunch of limits. That URL link has, we have a few examples in terms of VM sizes and limits, but the URL link has the exhaustive list, if you will. The choice of VMs can affect performance and depends on your workload, if you will. Different VM SKU selections allowed for the driver versus workers. And so cores can impact things like parallelism, how many tasks or Spark tasks are issued. Memory can impact JVM heap size. The SSD size and IOP limits can impact DB/IO cache or spills when you cache a data frame. And then the attached disk throughput limits. So this cache initially starts out on SSD and then has an auto scale where Databricks attaches additional disks to the VM. So the attached disk throughput limits can affect that DB/IO cache as well. And the network throughput limits of a VM can impact shuffle. So if you look at the standard DS3 V2, which is the default VM chosen for the cluster, it has 4 vCPUs, 14 gigs of memory. The first two columns are pretty self-explanatory, how many CPUs and how much memory. And each of the VM types also have a size associated with the SSD which is attached. So if the cache is filled up on that SSD, then additional disks are attached, and that's where the max uncached attached disk throughput comes into the picture in terms of IOPS. So choice of VM is extremely important in terms of performance. For example, GPUs would be used for machine learning type VMs, right? So that's the VM choice. From a storage perspective, what are your choices in terms of storage on the Azure platform, right? So when you create a workspace, by default, Databricks creates DBFS, which is a layer on top of Azure Storage. That storage itself, generally customers mount other file systems where they store the actual data. You don't store your actual data on DBFS, normally speaking. So your choices are effectively Azure Blob Storage or Azure Data Lake. Azure Blob Storage is a primary storage, it's a redundant, scalable, secure storage. It's available in it's considered a core Azure service. It's available in every region. There is a V2 version of the service which has enhanced throughput limits and size limits as well. And data is accessed via this primary key or a SAS token. A SAS token you can specify what permissions you have on a specific container, whether it's read or write or combination, and also has an expiry associated with the SAS token. So that's the recommended way. And then when it comes to Azure Data Lake Store, authentication or authorization to ADL is via Azure Active Directory. You create SPNs to secure folders within ADLS, or Azure Data Lake Store. One thing to be aware of, the region availability is a little less than Azure Blob Storage, but effectively both of these are storage options in Azure today. So how do you mount this external storage, right? So DBFS allows you to mount that, and why would you mount it? You would mount it so that you don't have to specify credentials each time. So these mounts are per workspace. So all clusters attached to the workspace can access these mounted file systems. There are no ACLs on the mount points per se. So these mount points are visible to all clusters in your workspace. So some of the code associated with it to mount, so the mounting code, effectively you specify the credential and the URL and the access token type for, the first part is the Azure Data Lake mount point, and the second part is the Azure Blob Storage mount point. So once you mount it, you just effectively mount it into a folder on DBFS. Your read after that effectively is just, as if it was a local drive, right? So read access is that way. So let's talk about integration experiences across different Azure services. So the first one we'll cover is SQL Server. So generally, before recently, everyone would connect. SQL Server or SQL DW often serve as your serving layer in your data pipeline. So you have Azure Databricks process some data, and you have the data served to dashboards by SQL Server. That's one option. SQL Data Warehouse, we'll talk in a bit, is another option. Generally, from a relational database side, the connector used is JDBC, but we've released a SQL Spark connector, which is extremely efficient for data loading itself. So on JDBC, what happens is when you specify a batch size on JDBC of, say, 10,000, the JDBC driver constructs a string of 10,000 insert statements, singleton insert statements. It doesn't use the bulk copy API. And so the insert of data load of any size is pretty slow. You hit latch contention, you hit, because they're singleton inserts. And in fact, you bump that batch size up to 100,000, your driver can run out of memory as well. So the SQL Spark connector has two options which do not exist. First of all, it uses the bulk API, the SQL bulk copy API, which is very efficient to load data into SQL Server. So it has the tab lock option and the batch size option, which are honored, and it's actually bulk copy, which is done within SQL Server. And you'll see some performance numbers in the next slide to do with it. So that's the recommended way from a loading perspective. So looking at some numbers with JDBC, and this is just a sample 120 million row record set, and details are in the blog. It's not an extremely wide table, but taking JDBC with an 8-node cluster and a SQL connector, you see the load size fundamentally different, right? It's extremely efficient compared to that. So a couple hints to remember: tab lock when you're loading into heaps, aka tables without any indexes. No tab lock when you're loading into anything with a column store index, which is like Parquet, which is columnar format and compressed. And then for column store, batch size should be 102,400 or greater, up to 1 million. And the reason why is when you load data into SQL Server that way, it goes into compressed row groups directly. It doesn't go into something called a delta store and that's compressed behind the scenes. It goes into compressed row groups directly. So that is the bulk connector. So how about data warehouse? So data warehouse is our MPP relational warehouse, which has a control node and a set of compute nodes. right? So if you invoke a JDBC call to read or write from the data warehouse, the connection is always to the control node. So all data actually has to flow through the control node, which can become a bottleneck for large data sets. So for a read of a large data set on data warehouse, again, we have a SQL DW connector, which is extremely helpful. If it's a small read of a few rows, it doesn't matter that you go to control node and get that information with just JDBC. For any large read or write, use the JDBC connector. So how does this happen? So you issue a load of a data frame in Spark. That in turn makes a JDBC connection to the control node, which talks to the compute nodes, and the compute nodes actually output Parquet files to blob storage, and this is a temp directory which you specify, and then those Parquet files are read by the individual worker nodes in Spark. And so for large reads of large data sets, this is much more efficient than every compute node sending the data to the head node and transferring data that way. So a couple options from this perspective. This is the JDBC connection string. This can be a table or a query. And then you have the temp directory, which is a directory. It can be a mounted directory, but it's an Azure Storage directory. So what about the load of a large data set? So that was a read of a large data set, right? So it's similar in mechanism where you save a data frame. That makes a JDBC connection and primes the SQL data warehouse with the metadata it requires. So it creates a scoped credential. Why does it need a scoped credential? Because it's going to read this data from Azure Blob Storage, right? The best way to load into a data warehouse, SQL data warehouse, is via Polybase. And Polybase, actually all the compute nodes individually load data into them rather than flowing the data through the head node or control node. So it creates the external data source in file format. And then the Spark cluster outputs the data it needs into Parquet format into this temp storage directory, which in turn, the data warehouse then reads this data. So that's the most efficient way to actually load data into the data warehouse. So a couple options from this perspective. Okay, this last arrow actually indicates we have some pre and post scripts. So if you want to prime, you want to capture logging of how long this load took, you can use the pre and post script. Or you want to create indexes after the load, you can use a post script, for example. Those are some examples around that. One common mistake people make is you have to create the database, master key, if you will, in order to create some of those scope credentials. That's one thing that people miss out, often. So Madhu will be taking us through the rest of this. So Madhu, all yours.
Thanks, Denzil. All right, so as you can see, the theme here is pretty straightforward, right? It's all about Spark being central to a lot of computing, and then the stores, whether it's SQL database, SQL DW, or now going on to CosmosDB. I don't know how many of you are familiar with CosmosDB, but it's a multi-modal distributed NoSQL offering from Azure. Again, you can use it with a Mongo API, you can use it with a Cassandra API, or you could just do a SQL API into it. As you can see, there's a common theme here. Pretty much Azure is trying to get a dedicated connector to Spark to efficiently read and write into any of these stores. So there's a couple of advantages to using this versus a low-level SDK that gets published out. Is basically you can take advantage of predicate pushdowns or indexing capabilities that these things provide, but also one cool thing with CosmosDB is it's got preferred regions when you actually connect to it, where if a region that your Spark cluster is operating, and most of the times a NoSQL database tend to be in a streaming scenario or a real-time lookup scenario, where if you have a preferred region and if the region has an outage, it can automatically go read from the other region. So you can pair a region and actually put it in the config and get that data available to your Spark cluster, or from a reads or writes point of view. The second one is query page size. That's pretty much how much data you want to load so that you can efficiently reduce the round trip that you would do. The last one is where it's taking advantage of a predicate pushdown, where you can say, where clause, which just get filtered on the CosmosDB side instead of getting all the data back onto Spark. So that's the streaming part, right, we just saw. Now, there are scenarios where I load my data nightly, right? If it's more like I got 3-hour window where I get some batch files I need to load into my NoSQL databases, but then I got to use Spark. The key to this thing is a bulk API. But again, there are some tweaks and tunings that we saw our customers were running into, and we had to develop some best practices here. Always use a bulk API in there, where you see the bulk import is true is the primary call. The second thing is the default batch size on this bulk API is 500. It's kind of low. We had to go up to 100,000 rows per each call. And then the key to this performance in a bulk loading situation was actually set the indexing to lazy, in the sense. So what happens is when you insert data into CosmosDB, it's indexing all the columns in there. So when you set it to lazy, it can do that work in the background while actually inserting all the data. So you got to set it to lazy, bring it back, load the data, and then set it to normal. That's a common practice we have seen for customers loading it in a batch mode. Also, a lot of times you got to monitor and increase your RUs. RUs are basically what define the throughput to a CosmosDB database. Obviously, the best practice is just like you load into a Cassandra database is try to match the Spark partitioning setup if you can with what you have on the CosmosDB side. So you can pretty much get that best practice out there. The last one is a larger page size to reduce the number of round trips that you do. A bulk API is used heavily, especially when dealing with CosmosDB. So next question was okay, how do I get a streaming pipeline enabled on Azure, right? Event Hubs is a native PubSub solution on Azure. We have a connector following the common theme here. We do have a specialized connector that can read and write from Spark to an Azure Event Hub. So it's following the same Spark paradigm. You got to config. You just have to get the keys from the portal, stick it in there, and then Spark.read stream. There's not a whole lot of complication there. It's pretty much a standard way to read, and then you read your data. There are some key interesting features that are coming up on this side of the world. You can, with a Kafka-enabled Event Hub, when you create an Event Hub, there is a flag that you can set saying enable this Event Hub for Kafka. You can treat it like a Kafka endpoint and read it from your Spark code. So there's no specific mention of saying I need to have an Event Hub related nomenclature. The connection string is all you need, but then the call would be like read from Kafka. That is a service that is on top of Event Hub. And Event Hub also has this auto-inflate feature where when you have a lot of data or a spike in data, it can actually auto-inflate to accommodate for the load increases and help you scale linearly. So next one that we see quite a bit is how do I operationalize my model, right? This comes in near and dear to a lot of us where people say, my data scientists love Databricks, workbooks, notebooks, whatever we have. We love the environment. They have a great way to play with it, but how do I take my model and operationalize it? So we do have an SDK that got published where you can take an Azure Machine Learning SDK today and deploy it on an Azure Kubernetes services, Azure Container Services, or on Azure Batch basically as a web service to serve your model. This is where you can enable it from a Databricks notebook. You don't have to get out of a Databricks notebook to get this thing done end to end. What does this look like, right? If you go look at it from your notebook, you import the library and basically say create my Azure Kubernetes service. Go call it, you give your resources that you want, and get the environment up and running. Once you have an Azure Kubernetes service set up available, you go say deploy my model out there as a web service that you can pretty much use. There's two key takeaways from this is now a data scientist can pretty much push out a model from his notebook. He can do A/B testing if needed. He can do a lot of things without actually going out to and reaching out to your DevOps or Cloud Ops or whatever teams you got to get this thing working. This is quite a bit of what you call happiness we saw when customers actually saw this feature, especially when they said, oh, I can actually run it as a web service and see how my model is deployed. So next thing is orchestration, right? Obviously, we got to move data from anywhere to anywhere. Azure Data Factory happens to be that key tool that we all have to primarily build things on. So you can, in this flow here, you can see that you can install a runtime agent or an on-prem setup, move the data from an on-prem database or a data source all the way to a Databricks job and then into a PowerBI dashboard. So this end-to-end orchestration is usually done using Azure Data Factory. Azure Data Factory basically has what's called as activities. Activities are basically copy my file from A to B is an activity. We do have a similar activity called kick off a Databricks notebook or a job. That's going to go spin up your cluster, run your notebook, run your job, shut it down, and then your data is available wherever you want it to be out there. So that's the integration with Azure Data Factory and a Databricks cluster at this point. And it uses your access tokens to actually go submit a job. The key here is not just the boundaries of Azure Data Factory doesn't end at just in Azure. It actually goes to your on-prem setup too. So best practices. So looking at all these things, what we have learned in the last year or so is, first of all, Azure Active Directory out of the box takes care of the authentication. It's got two-factor authentication. It takes care of knowing who you are. But then the missing piece is the authorization and the control mechanisms that you need that you have to configure. For example, if you have multiple business units and you don't want different units to see each other's libraries or each other's data, each other's code, if for whatever reason it is, you got to go at the Databricks workspace level. You can go create multiple workspaces within an organization so that you can have the most isolation. At the same time, there is advantage to having one workspace where you want some kind of sharing going on, but in those kind of scenarios, you need to have user access control, and the cluster access control needs to be enabled so that they can have those appropriate controls. That's at the Databricks workspace level, right? How about storage? So like Denzil pointed out, you can mount an ADLS or a blob storage, and then people can access it as a path on their DBFS. What that does is when you mount it, all the users have access using that service principal that you mounted the data on, right? So you want to have some controls on who can read it based on the workspace that it's mounted on, or sometimes it is not even an option where you say, I want to give different SAS tokens to different teams so that they can access it differently. I can have different service principals where somebody can only have read access to a certain data set, somebody else can just write. Out of the box, encryption is all there, default for a storage account, but if a customer wants, he can do a customer managed key on a storage account to encrypt the data. You can also enable table level ACLs so that the clusters can have some kind of RBAC mechanisms, where this is only for Python and SQL commands. Always recommended to use Databricks secrets to store credentials or connection strings, and it's I would say a must in an enterprise setup from what we have seen. So performance best practices. Going to the performance best practices, VM sizes obviously take a big chunk of it, where you really need to know the right kind of VM for the right kind of job. If you have a deep learning need, go pick up a GPU based cluster, else you're fine with a D14 or D3 like we just saw. Another one that is of importance is that is outside of Databricks is the storage account IOPS limit. So like everything on Azure, there is a soft limit and there is a hard limit. So soft limits are what, when you just go create a service, you get what's called a soft limit. So when you do a large cluster backed by a storage account, you quickly see some errors, even though the Spark job doesn't have any problem with it, but it's like writing or reading from it could be a problem. Those are all limits, and once you hit that, you can just request a ticket and get that bumped up. Or if you can predict ahead of time that I'm going to go need this much capacity, you can verify and then make sure that you have the IOPS limits raised on your storage account where you store your data. Region awareness is another key where we have seen customers think that they got an event hub somewhere in US East, and then next thing you know, they spun up a Spark cluster on US West, and the data is going over the network and internet for some time. So that's another thing you got to watch out that could affect your latency if you're reading from something like CosmosDB. Service scalability. Cloud is built for elasticity and scalability, where you can have a minimal footprint, and as you grow, you can grow. So as with everything, it is just like Databricks auto scale feature where you can scale up the cluster and scale it down. You also have scalability on each of those services, or most of the services that you have. There are always a way to scale it up based on your needs. So you can, some of them need explicitly setting that, saying, okay, enable the auto inflate feature. Some of them are automatically doing that for you. So there are some settings you got to just watch out for so that you can pick the right combination here. Last but not least, this is a quota thing, not so much on the real-time jobs, right? This is where you wanted a 100-node cluster. You might not have the quotas enabled on your account to say, I need 100 times whatever, 10 cores per machine or 16 cores per machine. I may not have that quota. It's just a good practice to go check on those when you actually go create a cluster. Sorry. Oops. Operational best practice. The last one is, again, so operations-wise, out of the box, Databricks puts the logs in a default location, right? It's great if you know them. If you want it in one specific location, you can always specify a custom location for your logs. You can also mount it to a blob storage where you actually have your data. So if you mount it to a blob storage, you can extract the log files and put it into something like log analytics, or other tools can make use of the log files, and you can get some kind of metrics for that. For DR, what we have seen customers do the workspace API export and import in another region so that they get their libraries, their notebooks in another region. But keep in mind, they only do right now, as of now, we only do the notebooks, the libraries, but not the access controls that are set up on those particular workspaces. For anything storage, Azure Storage Replication takes care of that. You need to set it up properly so that you can get it. Last one that's kind of tricky is the DBIO cache size, right? We don't know what is the local SSD size that's used. Maybe 6 months back when you set up the cluster, when your job is just started to run, it's all great, but your data volumes increased. You are spilling onto the disk, and then it's procuring another disk and adding to the VM where you are actually feeling that it's slowing down. We'll monitor those, and we can enable OMS monitoring with an init script. I don't know how many of you are familiar with OMS. OMS is basically an agent that runs on the VMs to monitor all the metrics that go on there. You can enable that with an init script, get all the the details of the CPU usage into your workspace. So here is how a sample OMS monitoring chart looks like once you enable an OMS monitoring. Cool. And any Q&A?
Yeah, we have time for just about one, maybe two questions max. Any questions before we wrap?
What does the Power BI integration look like with Databricks?
You want to take it?
Which one?
Power BI integration with Databricks, is there?
So there's a JDBC endpoint on the Databricks. That's the Power BI.
So it's via JDBC?
Yes.
Okay.
JDBC endpoint on the database cluster.
Yep.
Yeah.
Any more quick questions? Okay. There.
I have a question related to the partition. How the CosmosDB partition and Spark partition works. Because if I want to load the bulk data, like millions of records, how this is the partition related between these two?
So when you create a Databricks collection, you specify
CosmosDB collection.
Sorry, CosmosDB collection. Sorry, when you specify a CosmosDB collection, you specify the key And you got to, when you get the data in your data frame, you can repartition by that key and the number of partitions so that when it writes out, it does it in parallel. We can discuss, I can show you.
We'd love to chat with you a little bit more
I can
offline
give you
if you
more
want.
examples, yeah.
It's a little longer discussion than that.
Yeah.
But we are also available in the booth if anyone wants, swing by, ask any questions on anything Azure.
Thank you
guys.
again. You can catch our speakers right outside or at their booth. We appreciate it. Thanks, everyone.
Thank you.